Hello friends, welcome to this video. In this video we'll be discussing about countable sets. We'll see the definition, see one interesting example and give a trivial example of a countable set. So let's start with the definition. A set A is said to be a countable or countably infinite if a set A is said to be countable if it has bijection, I would say bijection with set of all natural numbers. What is meaning of this? Yes, this means that is there exists a bijective map. There exists a bijective map f from A to the set of all natural number. You can write it at from n to 8, that is also fine. If there exists from n to a, then there exists from a to n also, since it is bijective, inverse exists. So we know that a set is said to be countable if there exists a bijection between that set and set of a natural number. That is what? That is, my cardinality of A will be what? If there is a bijection between two sets, that means they have the same cardinality. In the previous videos, we have learned what is the cardinality of set of all natural numbers. It is denoted by alif naught. Correct? So this are nothing but requirement. Either of them is true, that means the set is countable. Means there is a bijection map, correct, or its cardinality is n, then you can say the set is countable. Okay. We will see the example. We will prove each and every example that I consider. But before starting with this, I want to talk about infinite set and a beautiful example. The name of the example is Hilbert paradox of the grain hotel. Okay. So if I put this example in my own word, or I'll try to explain it, I will say, suppose that you are a manager of an hotel. Okay. You will say, sir, BSc kar rahe. Right? You are a BSc student, but still assume that you are a manager of an hotel. The hotel has infinitely many, countably many infinite rooms. There is no end for the number of rooms, right? So there are infinitely many hotels and you are the manager for it. Okay. Now, one night, the hotel was completely filled, right? You know that all the rooms are filled. And late night, one VIP patient, VIP guest, right? No patient, we are in a hotel. So a VIP guest came. Now, he asked for the room and you can't say no. You have to fill him in some room, right? So what you will do in such a cases? Can you solve this problem? Important point is the hotel has infinite, countable, infinite number of rooms. So can you solve this problem? Can you use or apply our mathematics inside it? The answer is yes. You know that the number of rooms inside that hotel is nothing but alif naught, right? Set of all natural numbers, the cardinality of set of all natural numbers. Now, if one guest has arrived, can you adjust the other one in such a way the new guest, the VIP guest can adjust in the room? Yes, definitely. What you will do? Suppose this is nothing but room 1, this is nothing but room 2, this is nothing but room 3 and so on. What you will do? You will make the room 1 guest to go in room 2. Okay. The room 2 guest to go in room 3. Room 3 guest will go in room 4. Like the way everyone will go to the room number which is next to their previous number, right? So what you did, you just send a guest from the room number n to n plus 1 and you will see this set is totally fine, correct? Everyone will get some room. Also, you got one empty room also. So the new VIP guest can stay in this room. So what you did? You define a map n to n plus 1. Okay. So what is that map? F from set of all natural numbers. What you did? You just took it from 2, 3 and till infinity. Now if you observe, this map is nothing but a bijective map. Correct? This map is bijective. That means what? This set of all natural number and this set has the same cardinality. Correct? So what I see is this is nothing but a proper subset of it, but still it has a bijection with n. It is possible only inside infinite set. Infinite set, this thing is not possible. You cannot have a bijection with its proper subset. Over here, you see this set is nothing but a proper subset of a natural numbers, but still it has a bijection. That means this set also has cardinality alif naught. This set is also countable set. Correct? Okay. Now let us just make this problem more interesting. Again, you are the manager of the same hotel. Next night hotel is already filled, but now countably many infinite guest arises and you want to fill them. Now again we'll apply some logic like that, similar only. So you have 1 2 3 4 5 6 and so on, right? These are nothing but room. 1 2 3 4 5 6. Okay, so now you want to fill countably many guests inside the rooms which are already filled. You know that there are countably many and they are filled, right? So what you will do in this case, what you will do is you will send this first guest to the second room, the guest in the second room to the fourth one, correct? Since this person was already there, we here there will be 1 2, right? So this person went to the fourth room. Okay, so by that, okay, so the second person went over here, the third person will go in the sixth room, okay? The fourth person will go in the eighth room, the fifth person will go in a 10th room. Yes, you can guess now what I'm doing. I'm sending the guest in the room number n to 2n, correct? By doing this, what happens is my all room numbers which are of odd, means this room number 1, room number 3, room number 5, room number 7, room number 9, room number 11 and so on. All this countably many infinite rooms becomes empty now, correct? So by using this, I can fill those new countably many infinite guests in already filled hotel. So the map is nothing but this. Again, the map is what? Map is nothing but n getting mapped to 2 4 6, right? 2 4 6 and so on, all even numbers, right? Again, since there will be a bijection, similar logic I am applying, right? So if you have any doubt, just write in the comment box. So this again is a bijection, you guys can prove it if not, okay. So now I know that's the set having the cardinality alif and on. So again we learn an infinite set has its proper subset which has the same cardinality. An infinite set can have a bijection with its proper subset. Okay, so this is nothing but a Hilbert's paradox of a grand hotel. If you see the problems on a finite set, it is impossible, right? But the same thing is possible when you have countably many infinite rooms. Otherwise, this problem is impossible, right? You cannot fill even one customer if you have only finitely many rooms and all of them are filled. Correct? Okay. So let's go ahead and see a trivial example now. It's over here. Example is Z. The set of all integer is a countably infinite set. Countably infinite, we just learned, that means it has a cardinality alif non. That is, it has a bijection with set of all natural numbers. Okay. So I need to prove this. I need to define a map, correct? So can you think about the map? Yes, it's really trivial. If I give you, it is f is nothing but from z to set of all natural numbers given by, so over here I have all integers. I have 0, -1, -2, -3, 1, 2, 3 and all, right? Over here I just have 1, 2, 3. So I have to think in my head, I need to cover 0 and all negative integers. So what I did is, I map f of x to 2x if my x is a positive integer. I map it to -2x plus 1 if my x is negative integer or it is 0. Okay, let's see this map. Is this map well defined? First of all, okay, it is well defined. Why? Because if I consider a positive number, it will get mapped to 2 of x. So a element goes to a single element. Similarly, if I consider 0 or I consider a negative number, then it will get mapped to -2x plus 1. So since a single element goes to a single element, it is a well defined map. Now what will be our task? Our first task will be to show that my f is 1 1. Okay, let's just prove this. So my f is 1 1. How I will prove? So what I will consider? I will consider f of x equal to f of y. Let f of x be equal to f of y. I need to show that my x must be same as y. Okay. So first thing, if my f of x is same as f of y, can my x be even number and y be an odd number? Can you think about it? Let's just think. Suppose if my x is, even number odd, I went in that wrong path. My x is greater than 0 and y is less than 0. Suppose, okay, sorry for mistake, but I just came to path again. So suppose my x is greater than 0 and my y is less than 0. Is it possible? If my x is greater than 0, then my f of x is nothing but 2x, even number. Correct? It is even. If since my y is less than 0, or less than or equal to 0, you said. Correct? So f of y will be minus 2y plus 1, which is an odd number. Is it possible? An even number is same as odd number? Not possible. Correct? So I know that this case, therefore, a contradiction. So the sign of both x and y cannot be different. If my f of x is same as f of y, I know that either both of them are greater than 0 or both of them are less than or equal to 0. So I will consider in that sense. Okay. So for x comma y greater than 0, my f of x, I'm considering this as a case, okay? And then I will consider for x and y less than or equal to 0. I know that both cannot be of a different sign. So my f of x will be what? Since it is greater than 0, it will be 2x. F of y will be what? It will be 2y. And I know these two are same. This implies my x must be same as y. Correct? It's so trivial. Similarly over here, since my x and y are less than or equal to 0, I know my f of x is same as minus 2x plus 1. And my f of y is same as minus 2y plus 1. Since these two are same, my x and y must be same. You can cancel this, right? Implies mean my f is in 1-1 map. Okay? It's so trivial. Okay, so I have wrote something over here. I need to rub this, can I? Okay, just write this thing down. I'll rub this. Okay. So now what will be our claim, my dear friends? Our claim will be to show that my f is an onto map. Let us just think about it. So my second claim, to show that f is an onto map. Okay. So you can pause the video and try to do it by yourself. If not, just come over here again. So I know that my codomain was set of all natural numbers. So what I consider, let my y be any natural number. What I want, I just want a pre-image for this. Now, y is a natural number, and I know that by definition of my map, I map some element to an even number, some element to an odd number. Correct? So if my this y is an even number, I will think like that. And if my y is odd number, then I will think like that. Okay. So if y is even, then y must be pre-image for what? Just consider this. If y is even means nothing but over here we are considering this case, correct? That means whatever is pre-image must be greater than 0. And also it is half of that y, since 2x is nothing but image of x. Okay, so in that sense my f of y by 2 is same as y. Correct? Is it okay? My f of y by 2, since y is a natural number, my y is greater than 0. Also, since it is an even number, y by 2 is an integer. Now this y by 2, since my y by 2 is number greater than 0, also my y by 2 is a integer only, right? It is an integer only. So is it fine? No doubt over here. Now I'll consider if my y is odd. If my y is odd, then we think about the function again. If y odd means it should look like this. It should be pre-image of what? If you consider f of, I know that from the map, then element will get to odd number if and only if that number is less than or equal to 0. That means I know that pre-image will be what? Pre-image will be something which is less than or equal to 0. Correct? So I'm just thinking about it. I want a negative integer. So what I consider is, I consider this minus y minus 1 by 2. If you consider this, since it is a negative integer, I know it will get mapped to where? By the definition of my map, it is getting mapped to minus 2 times that element plus 1. Okay. So it is minus 2 times that element minus y minus 1 by 2, that thing plus 1. So that is same as what? That is same as 2 will get cancelled. So I no need to write this 2. So that 2 get cancelled, minus minus. So it is y that here I should have plus 1, right? Otherwise it is not coming out to be the way we want it. Oh, okay, no, here there is a bracket, since I consider this minus outside. Oh, now this is fine, right? So I just took, by mistakenly I just took that y only to this y, but it is to the entire one, so it becomes this minus, so it is minus 1 plus 1, right? Yes, so it become y. That means this element is nothing but pre-image of this y if my y is an odd number. Correct? So if y is an even number, my y by 2 is the pre-image. If y is an odd number, then minus of y minus 1 by 2 is the pre-image. Hence, in both of the possible cases inside natural numbers, by f is an onto. That means what? Implies f is onto, implies f is bijective. Correct? F is bijective, and f is bijective implies me what? My set of integer is countable set, or I will say countably infinite set. Okay, I will just keep a habit of writing countable infinite set. Okay, later on I will tell you why I am just keeping a habit of writing countable infinite set. But for now, I think it is enough for this video. If you like this video, just subscribe to the channel and give your suggestion in the comment box. Okay, thank you.